Assalamualaikum and good morning everyone. We would like to present about our mini project which is smart control system featuring DC motor, LED and 3-position rotary interface. First of all, my name is Siti Shazwana binti Nur Hisham and my matric number is 10DTK23F1009.
My name is Ayuni binti Alias and my matric number is 10DTK23F1017.
Selamat sejahtera kepada semua. Nama saya Jishla Joyce dan nama matrik saya 10DTK23F1010.
Hello, my name is Atira binti Bidom. My matrix number is 10DTK23F1007.
My name is Anisa Dana binti Mahfuz 10DTK23F1002.
So for introduction, this mini project focuses on designing a simple control system using a DC motor, LED and 3-position rotary switch, where each switch position control the motor and LED in different ways. For example, one position may turn everything off while the others can control different motor speed and LED indicators. The system is powered by a microcontroller which reads the switch input and send the correct output signal to the motor and LED. This type of system is commonly used in real-world applications like fan speed controller or mood selectors in home appliances. By working on this project, we learn how to interface input rotary switch and output devices DC motor and LED with a microcontroller and how to write a logic control them based on user input. It's a great hands-on way to understand the basics of embedded system and automation.
So for appropriate equipment or component, first we should have DC motor, 3-position rotary switch, LED, resistor, motor driver, power supply, microcontroller and last but not least, jumper wires. Next, I will present about this project. This project illustrates the logic of a control system using a 3-position rotary switch to control an LED and a DC motor. The system continuously monitors the switch position. In position 1, only the LED is activated while the motor remains off. In position 2, the LED is turned off and the motor is activated. In position 3, both the LED and the motor are turned on. This project clearly represents how the system responds to different switch positions in real time, ensuring reliable and efficient operation.
So now I am going to present the Gantt chart of our presentation. So as you can see, the duration of our presentation was from week 7 till week 14. And total overall we had 9 tasks. So the first task was the topic selection and planning, and then we had to research on the PIC 18 internal features, and then we designed the system architecture, and then we did the circuit simulation by using Proteus app, and after that we concluded we did the coding in MPLab, and then we copied the coding and inserted it into our circuit diagram in Proteus, and then we did the hardware implementation, testing and troubleshooting, and then we wrote the report, and finally we submitted our presentation. So that is what happened from week 7 till week 14 for our presentation. Okay, so next I am going to talk about the programming that we have used, or the coding that we have used for our mini project. So we did DC motor control using PIC 18F45K22 with PWM. So this program controls a DC motor using the PIC 18F microcontroller. So the purpose of each of this coding, I'll explain each of the coding that we use. So first we had a LED-C, which is used to speed the control of the PWM, and then we had LED C4, which is LED C4 and also LED C3 to control the directions of the motor, and then port E, which is the RE0, RE1 and RE2 as input buttons, and then RE0 is to stop the motor where PWM is equals to 0, and then RE1 sets the medium speed for the PWM, which is equals to 60, and then RE2 sets high speed. So RE1 is to set medium speed, which is 60, and then for RE2 it sets the high speed, which is 249. And then we had timer 2 and CCPI module to configure the PWM generation. So this setup, it allows the motor to run at different speeds and in one direction based on the buttons input. So that's all for the programming part. Thank you.
I will present the motor control system design using PIC 18F45K22 microcontroller. This is a circuit demonstrate how a microcontroller can control the speed of a DC motor and the brightness of an LED using a rotary switch. This is a circuit of the system. The PIC 18F45K22 read input from a rotary switch and control an L293D motor driver, which a driver DC motor. The LED provide visual feedback, and the system allow switch between a low and high speed motor operation. The components used in this project included PIC 18F45K22 microcontroller, L293D motor driver, DC motor, yellow LED with 100 ohm resistor, rotary switch 3 position, pull up resistor 10k ohm. These are arranged in this process simulation environment. This is the result after we run simulation. When the rotary switch is in the low position, the microcontroller read this position and send a control signal to the motor driver to activate the DC motor at a low speed. The motor run at a gentle speed suitable for a low power application, and the LED emit a dim light for a visual indication. When the rotary switch is in the high position, the microcontroller detects this mute and command the motor driver to increase the speed of the DC motor to a higher level. The motor operates at a faster speed suitable for a high power task, and the LED be shine brightly to indicate maximum output intensity.
In conclusion, this project successfully demonstrates a basic control system using a DC motor, LED, and 3-position rotary switch. Each switch position provides a different function, allowing users to interact with the system and observe changes in motor operation and LED status. The microcontroller handles input detection and output control efficiently, proving how embedded system can automate simple tasks. Through this project, we gain valuable experience in hardware interfacing, microcontroller programming, and logic implementation. It also helps us understand how such system can be applied in real-life situations like speed control, device mode selection, and automation processes.